Howdy, howdy, chemistry students. This is going to be a video that covers the progression of the atomic models. So we're going to look at how the atomic models have changed throughout the years. And we talked about this a little bit, but the work of Dalton, Thomson, and Rutherford began an age of exploration that culminated with a model of the atom that described a dense nucleus surrounded by electrons. This model continued to be modified as more data was collected. So let's look at how the atomic model has changed. We know that in the 90s, Niels Bohr did most of his work in the 40s and 50s. The Bohr model is what we imagine when we think of an atom. We have this nucleus that has rings around it. We also call it the planetary model. But the electrons are arranged in circular patterns, orbits, which is why we call it the planetary model. Electrons have particular paths with fixed energy, which we call energy levels. So perhaps in junior high you learned that maybe this first energy level is n equals 1, and this is n equals 2, but these are energy levels. And maybe you learned that we can only have 2 electrons in the first orbit. And then perhaps you remember that we could have 8 in the second orbit. Well, this was Bohr's model, but since then we have changed, and we got to learn how it has changed. So our newest and most up-to-date model is actually called the quantum mechanical model, and it comes from mathematical solutions to what we call the Schrödinger equation. And the probability of finding an electron with a certain volume of space surrounding the nucleus can be represented by clouds. So I think you guys have heard of electron clouds before, but that's what the quantum mechanical model represents with mathematics and with computer software. The cloud represents where the electrons can be found about 90% of the time. So instead of just having orbits and circles, you have these three-dimensional shapes, which we call orbits, or electron clouds. And we'll learn in a little bit how many electrons can be in each cloud and how many clouds there actually are. We call those electron configurations. So again, these clouds that we're seeing is where we can find an electron 90% of the time. They're flying around at speeds that are just incredible. And so we have a probability that tells us where they would be. So what I want us to do is actually go ahead and summarize all of the atomic models that we're going to see and focus on, after this, we're going to focus on the one that we use the most. So we have Dalton's, we have Thomson's plum pudding, Rutherford's atom after he discovered the nucleus with the gold foil, Bohr's planetary model, and then our current model, which is quantum mechanical. So I'm going to go ahead and exit out of the PowerPoint, and I want to go ahead and walk you through some of these examples here. I think I should be able to draw some of these in here for you. Let's see. Okay, let's come over here. All right, so the Thomson model came after the Dalton model. So again, the Dalton model is a perfect sphere. Solid sphere, it's indivisible, we can't break it apart. But then Dalton came along and he put together a model that had negatively charged electrons, which we call the plum pudding model. And he said that there was positively charged material floating in between, kind of like the cytoplasm of a cell. So what are we going to say here? Let's go ahead and say that we have the plum pudding model. I'm going to call it electron pods with positive, and if you want to use the word cytoplasm, you can. Okay, then Rutherford came along and he changed just a little bit. He said that we've got this nucleus that has positive charges, and he actually didn't know about the neutron yet, so I'm not going to draw neutrons there. And he did say that he agreed with Thompson's negatively charged electrons floating around on the outside. So this is how Rutherford's changed. And so if I'm filling this in, what I'm going to say is that Rutherford had a central positive nucleus. And I'm going to put that it had a dense core with electrons on the outside. Okay? Bohr's model changed a little bit. And this is when Bohr came out and said that he had the nucleus that had protons and neutrons in it. And he said that electrons were in rings around the outside. So what are we going to say here? We're going to say that we have a nucleus with protons and neutrons. Electrons are orbiting in circles. And then last but not least, this is going to be our most up-to-date quantum mechanical model. We do have the nucleus in the center, but what we have are electron clouds. And as we grow, the clouds get bigger and bigger, and we'll learn about the shapes. So I'll leave it there. I don't want to get too fancy. So let's say that we have electron clouds around the nucleus. Okay, and we'll go ahead and stop there for today.